Imagine an invisible force field, a colossal bubble of energy surrounding our entire planet. It's not science fiction, it's a reality of our cosmic existence. This is Earth's magnetic field, a silent guardian that stretches thousands of kilometers into space. Without it, our world would be a very different place, constantly bombarded by dangerous high-energy particles streaming from the sun. This field is our planetary shield, deflecting the relentless solar wind and protecting the very fabric of life. It's what makes our world a safe harbor in the vast, often violent, cosmic ocean. We can't see it or touch it, but its presence is fundamental to our survival, a quiet hero in the story of life on Earth. So, where does this magnificent shield come from? The answer lies deep beneath our feet, thousands of kilometers below the surface we walk on. Our planet has a heart of iron. The outer core is a vast, churning ocean of molten metal, hotter than the surface of the sun. The immense heat from the solid inner core causes this liquid iron to swirl and flow in massive, complex currents. This movement of electrically conductive liquid iron generates powerful electric currents. And, as the laws of physics dictate, moving electric charges create a magnetic field. This entire process, known as the Geodynamo, transforms our planet into a gigantic magnet with a north and a south pole. This planetary engine is not perfectly steady. The flow of molten iron is chaotic and turbulent, more like a boiling pot of water than a smoothly spinning top. Because of this, our magnetic poles are not fixed points on the map. They wander. The magnetic North Pole, the point your compass needle desperately tries to find, is currently drifting from the Canadian Arctic towards Siberia. This restlessness is a fundamental characteristic of our magnetic field. It's a dynamic, ever-changing system, a cosmic dance of liquid metal and energy that has been playing out for billions of years, shaping our world in ways we are only just beginning to fully comprehend. But this wandering is just a hint of something far more dramatic. Throughout Earth's long history, this magnetic field has not just shifted, it has completely flipped. The North Pole has become the South Pole, and the South Pole has become the North. This incredible phenomenon is called a geomagnetic reversal. It's not a question of if it will happen again, but when. These reversals are a natural, albeit chaotic, part of our planet's life cycle. They are written into the very rock of our world, a testament to the dynamic and sometimes violent nature of the forces that operate deep within our home planet, reminding us that even the most fundamental forces of nature are in a constant state of flux. How can we possibly know what Earth's magnetic field was doing hundreds of thousands or even millions of years ago? We can't travel back in time, but our planet has provided us with a remarkable geological library. The story of past reversals is locked away in ancient rocks, waiting for us to read it. The science of reading this history is called paleomagnetism, which literally means ancient magnetism. It relies on a simple but elegant process. When volcanoes erupt, they spew out hot, molten lava. This lava is rich in tiny iron-bearing minerals, like magnetite. As the lava cools and solidifies into rock, these minerals act like microscopic compass needles. As the rock cools past a certain temperature, known as the Curie point, the magnetic orientations of these tiny mineral grains are frozen in place. They become permanently aligned with the direction and intensity of Earth's magnetic field at that exact moment in time. They are a snapshot, a fossilized record of the magnetic field from a bygone era. By studying volcanic rock layers from different time periods all over the world, geologists can piece together a timeline of the Earth's magnetic history. Each layer tells a part of the story, revealing when the field was stable, when it was weak, and when it completely flipped its polarity. This geological barcode of magnetic stripes reveals that reversals are a regular, if unpredictable, feature of our planet. They don't happen on a neat schedule. Sometimes millions of years can pass between flips, while at other times, they can occur more frequently, every few 100,000 years. The last full reversal, known as the Brunhes-Matuyama reversal, happened about 780,000 years ago. At that time, our early human ancestors, like Homo erectus, were walking the Earth, likely unaware of the grand celestial drama unfolding invisibly around them. They coexisted with megafauna, and the planet was a very different place. The rock record also tells us that a reversal is not an instantaneous event. It doesn't happen overnight. The process is messy, and drawn out, likely taking thousands of years to complete. During this transitional period, the main magnetic field weakens significantly, perhaps to as little as 10% of its current strength. It can become chaotic, with multiple temporary north and south poles sprouting up in unusual locations all over the globe. For a time, the simple two-pole structure we know today would vanish, replaced by a complex and jumbled magnetic surface, before it eventually re-establishes itself, with the poles in their new opposite configuration. Is it possible that we are living on the cusp of the next great magnetic reversal? Scientists are constantly monitoring the health of our magnetic field, and they have identified a particularly curious and growing feature. It's a vast region of unusual magnetic weakness stretching from South America across the southern Atlantic Ocean. This area is known as the South Atlantic Anomaly. Here the magnetic field is so weak that the protective shield is closer to the planet's surface. This means that particles from space, which are normally deflected, can dip lower into the atmosphere, causing potential problems for orbiting satellites. This anomaly is not a new discovery, but it is a dynamic one. Data from satellites shows that it is growing in size and deepening, and it appears to be splitting into two separate lobes or centers of minimum intensity. The intensity of the magnetic field in this region has decreased significantly over the last 2 centuries. This has led to a great deal of scientific speculation. Is the South Atlantic Anomaly a sign that the geodynamo in the core is becoming more unstable? Could this be the beginning, the first rumblings, of a complete geomagnetic reversal? Or is it simply a temporary fluctuation, a magnetic pothole that will eventually repair itself? The honest answer is, we don't know for sure. The processes happening in Earth's core are incredibly complex and hidden from direct view. We rely on indirect measurements and sophisticated computer models to try and understand what is happening down there. The South Atlantic Anomaly could very well be a precursor to a flip. The kind of magnetic instability that the rock record shows has happened many times before. It represents one of the most significant changes in the geomagnetic field in recent history, and for that reason alone, it commands our attention and requires continuous study to understand its evolution and implications. However, it's also important to maintain perspective. The Earth's magnetic field is a chaotic system, and not every wobble leads to a complete collapse and reversal. It could be that this is just a regional quirk, a temporary weakening that will not spread globally. Think of it like a persistent storm system in the atmosphere. It's a significant weather event, but it doesn't mean the entire global climate system is about to collapse. Scientists are using an array of ground-based observatories and satellites to keep a close watch, gathering data that will hopefully help us distinguish between a temporary storm and the prologue to a planetary-scale transformation. If the poles do flip, what would it mean for life on Earth? The idea of our planet's fundamental orientation changing sounds apocalyptic, but the fossil record tells a different story. There is no evidence to suggest that past geomagnetic reversals have caused mass extinctions. Life, in its magnificent adaptability, seems to have been largely unfazed. Ancient bacteria, our early human ancestors, and countless other species have lived through these events and survived. While the weakened field would allow more solar radiation to reach the surface, our atmosphere still provides substantial protection. It wouldn't be a sterilizing event. Many species, from sea turtles and migrating birds to whales and even bees, are known to use the magnetic field for navigation. A reversal would certainly be confusing for them. Imagine your compass suddenly pointing south instead of north. These creatures might become disoriented, and their migratory paths could be disrupted. However, life is resilient. These animals often have backup navigation systems, using the sun, stars, or their sense of smell. Over the generations, it's highly likely that they would adapt to the new magnetic reality, just as their ancestors did during the hundreds of reversals that came before. Evolution is a powerful force for adaptation. The real vulnerability in a modern reversal lies not with biology, but with our technology. We have built a global civilization that is exquisitely dependent on electricity and satellites. During the transition, when the magnetic shield is weak and chaotic, our technological infrastructure would be at a much greater risk from solar flares and cosmic rays. A powerful solar storm, which our current field might deflect, could overwhelm our electrical grids, causing widespread blackouts. Satellites, which are crucial for communication, GPS navigation and weather forecasting, would be more susceptible to damage from radiation, potentially being knocked out of service. The challenge, then, is not one of survival, but of preparation. Astronauts in orbit would require enhanced shielding to protect them from increased radiation levels. We would need to design more robust satellites and develop strategies to protect our power grids from solar-induced electrical surges. A geomagnetic reversal is a low-probability, high-impact event. It is a slow-moving, natural process that unfolds over timescales far beyond a human lifetime. It's a reminder that we live on a dynamic planet, and our own ingenuity will be key to navigating the changes, ensuring our technological civilization can weather the storm, just as life itself has done time and time again.